Alright, here we go. We got lecture 4.3, Properties of Logarithms. For those of you following along in the textbook, this is section 6.5. Alright. Now, this is where you're going to pull out your calculator for the first formula. It's called the change of base formula. It turns out when you're working with logarithms, you can change the base to any base your heart desires. The catch is that your one logarithm will be expressed as a ratio of two logarithms. So here we have a log base b. B can be, any positive constant. Besides 1, of course. So we got base b, and suppose I want to change it to base c. I can. It's just the base b is going to be the input in the bottom, and the input is going to be the input in the numerator, just like that. And you can change it to whatever base you want. Now, the most popular change of base is to the natural logarithm. So if I have log base b, and b is for bums, and I want to change it to the natural logarithm because that's naturally preferred, I don't know what I'm saying. I'm just saying lame stuff. But for whatever reason, suppose you want to switch it to a natural logarithm, you can. It'll also be natural log in the numerator, natural log in the denominator. Old base goes to bottom. Input goes to top. So where this is very useful is for using modern scientific calculators is one application. So if you look at your calculator, and I recommend you go ahead and pull it out now. Now some of you might have a calculator that lets you type in the base. But most calculators, or at least a lot of calculators, they don't let you select the base. They just have an LN button or a log button. Now the log button is base 10. All right, it doesn't let you choose it. So let's look at this example. Round log base 2 of 5 to 4 decimal places. So it's saying, hey, 2 to what power equals 5? Now, I know it's going to be bigger than 2 because 2 squared is 4, but it's going to be less than 3 because 2 cubed is 8. So the number is somewhere in between 2 and 3. And I want to go ahead and round that number to 4 decimal places. Now, if you look at your calculator, there's no log base 2 button. So I just have an LN button on my calculator. Well, I can use that. And here's what I'm going to type into my calculator. It's just going to be ln of 5 over ln of 2. And that's what I'll type into the calculator. The idea is, old base going towards the bottom. Old input going into the numerator. So if I type that into my calculator, I can go ahead and round that constant to 5 decimal places. And again, it should be in between 2 and 3. It is. I get 2.3219. And that makes sense that the constant is a little closer to 2 than it is to 3, because 5 is a little closer to 4 than it is to 8. Alright, so that's the change of base formula. Again, very useful for those of you using a standard scientific calculator. If you want to round your solutions. We're going to go ahead and move on to property 1 and 2. Now, property 1 and 2 basically state that if you take a base A exponential and put it inside of a base A logarithm, they will cancel out. Property 2 says if you take a base A logarithm and put it into a base A exponential, they'll cancel out. So, we already talked about this. We did this in test 2. If you go back to test 2, the very last topic we covered in unit 2 was inverse functions, and we had a theorem that says, hey, inverse functions when composed together will cancel out. Well, that's what's going on here. What's the opposite of a base A exponential? A base A logarithm. So if you apply those to each other, they cancel out. So let's go ahead and practice with this. So here we have a log base 7 applied to a base 7 exponential. They cancel out, leaving just the 500. Another way of looking at this is that you're saying, hey, 7 raised to what power equals 7 raised to the 500? Oh, 500. The answer is in the question itself. So ln is base e, so that's going to cancel with the base e exponential, just leaving x plus 3. Here we have 5 raised to log base 5, so those cancel out, leaving just the input, which is y. In example 4, we have 7 raised to log base 7. Those cancel out, leaving us 31. Alright, so property 1 and 2, pretty straightforward. If they are the same base, they will cancel out. Alright, let's look at property 3, 4, and 5. We're going to go ahead and tackle all these together. Now, these are for all intents and purposes, you can view these as the logarithm version of some exponential properties. So property 3 states, hey, multiplication translates into an additive property. And we see that with exponents. 5x squared times x cubed, well, that equals x to the fifth. How do we get that? You add the powers. So when it comes to exponents, multiplication translates into a form of addition, so to speak. Well, it's no different for the logarithms. This is just the logarithm version of that rule. And remember, logarithms are directly tied to exponentials. So a lot of properties you have for exponentials are going to have, typically, not all, but a lot of them are going to have some logarithm cousin, so to speak. Property 4 states division translates into a subtractive property, which makes sense. 5x to the fifth divided by x cubed, well, that equals x squared. You get it by subtracting the powers. We're just looking at the logarithm version of that. And then property 5, this is a corollary of property 3, basically stating that if you have an exponent, you can pull it out as a coefficient. This property 5 is going to be the most useful. Now, do be aware of property 5, they don't cancel out because it's a base a logarithm with a base x exponential. They'll only cancel if they're the same base, which is not what we have here. So let's look at this example. Now, some of you have a fancy calculator and be like, oh, well, I don't need to know these properties to evaluate these logarithms. I'll just type them into my calculator. Okay, be my guest. Oh, wait, go ahead. Let me, I've got a tasty monster here. Let me take a sip. How'd that work out for you? Did you get an error message? You probably got something called overflow error. So know that you are smarter than your calculator, right? There are certain problems your calculator cannot do, but you can. So if you're smart, you'll realize, oh, hey, that's an exponent. I understand logarithms. I can pull that out front. So this equals 700 times log base 3 of 9. Oh, okay, that's easy. That's a 700 times 2. You know, log base 3 of 9 just equals 2. You're saying, hey, 3 to what power equals 9? That's 2. 700 times 2, we don't need a calculator for that. Answer is 1400. So same thing with number 2. You know, pull the power out front, and then it's pretty straightforward from there. Log base 5 of 25. Well, what power of 5 gives you 25? That would be dos, amigo, giving us 34. Let's look at number 3. You know, pull that factor out front. So then we ask, okay, 2 to what power equals 1/8? Well, I know it's going to be some variation of 3 because 2 cubed is 8, and it's negative because of the fraction. Right? That gives us the reciprocal. So here the simplified answer is negative 900. Alright, so that's just playing with property 5. Out of all the properties of logarithms, property 5 is probably going to be the one we use most frequently. We're going to be using that a lot in the next section when we start solving equations. But let's just go ahead and play. So let me go ahead and rewrite this. So remember, properties of exponents, we can take any root and represent it as a rational exponent. So square root of x minus 1 is the same thing as a power of 1/2. Remember, a square root is the same thing as a power of 1/2. A cube root is the same thing as a power of 1/3. A seventh root is the same thing as a power of 1/7. So if we look at our properties, property 3 and 4 to be specific, basically states that multiplication gives us an additive property, division gives us a subtractive property. So basically, all of our factors in the numerator of the input are just going to be our positive terms. All the factors in the denominator of the input are going to be our negative terms, and they're all going to be natural log. So we have 3 times, now anytime you have multiplication, you can add another term, times x minus 1, and that's raised to the 1/2. Now going to the denominator, that means I'm going to write subtraction, natural log of 2. I'm writing a minus, negative, because it's in the denominator, minus natural log of x plus 3 raised to the 5th. So if you see, All of our positive terms come from the numerator. All of our negative terms are coming from the denominator. And then we just pull the powers out, and we're done. So nothing to do with ln of 3. Here we can pull the 1/2 out front. Here we nothing to do with natural log of 2, and here we can pull the 5 out front. And this is as expanded as we can get. Just a word of warning, you cannot expand logarithms over addition and subtraction. There's nothing more we can do with the x minus 1, nothing more we can do with the x plus 3. They only expand over multiplication and division. Let's look at another one of these expansion problems. So, this is going to expand to a string of log base 3s, so I have 2 in the numerator. X to the 7th in the numerator. I'll pull the 7 out front. It's positive because it's in the numerator. Then I got x minus 3 to the 4th in the numerator. I can pull the 4 out front, and then it's x minus 3 is positive because it comes from the numerator. And then that x plus 5 raised to the 11th is in the denominator, so it's going to be a minus sign. Pull the power out front, and we are done. We have expanded the logarithm. So again, numerator factors give you positive terms, denominator factors will give you negative terms. The next two examples are just reversing that process. So here we can combine all of these into a single logarithm because it's just a bunch of log base 2's added together. Now if they have a different base, you cannot combine them. We can only combine log base 2's with other log base 2's. We can only combine natural logs with other natural logs, and so on and so forth. So we got x to the 7th, that is positive going to the top. That's going to be 3 cubed going to the top, and then a cube root of x plus 5 going to the top. So I got, let's do the number first. 3 cubed is 27, x to the 7, and then the cube root of x plus 5. And then this is the only negative term, so that's the only thing that's going to end up in the denominator is x plus 1 raised to the 5th. So all I'm doing is doing the previous problem in reverse. Alright, let's do one more of these. So all of these will combine into a single natural log. So 3 goes to numerator. X plus 2 to the 4th, denominator. X cubed, denominator, because it's negative. X plus 15, numerator, because it's positive. It's that easy. Bada bing, bada boom. We're done. Alright, that is a wrap on properties of logarithms. I've covered everything that's on worksheet 6. So guys, you are ready to roll in that worksheet 6. And for those of you that are my students in summer 2020, have a wonderful Independence Day. And please be safe as you are celebrating the birth of the only nation to make it to the moon. So guys, again, please be safe out there and have a wonderful day.